Well, my name is Pradeepta Mishra, so I have close to 10 plus years of experience into predictive modeling and data science. And I have written 2 books on data science and text mining. And apart from that, I do deliver talks more often on machine learning, artificial intelligence in various B schools and colleges. And I'm also visiting faculty in many of the B schools who are offering this data science and machine learning courses. This is briefly about myself. So I'll be talking more on like what is data science and what is machine learning, what is AI, and why things are changing around us. What exactly changing around us, and what we should do, and what is the way forward. So I'll be talking about a lot of like AI examples, applications, where machine learning sits in between these applications, and how data science is particularly plays a very important role in this AI and machine learning journey. Okay, so and please stop me anywhere if you have any questions on any slide. Okay, fine. So more questions. So whatever questions you have, you keep asking me. Fine, sure. Well, so I'll start with first, what is data science? So now last couple of years, maybe 2-3 years, we are hearing a lot of things around data science. What is exactly data science? It was already there, statistical modeling was already there. So like why we need to create or maybe a separate field as data science? Right, so that's a very common question that usually you may have while looking at various blogs, articles, or various things online, right? So data science is basically the science of extracting insights from data. Each and every data point, whatever field, maybe it is applications, Android applications, web applications, whatever activities you do, simply if you are just tracking your journey from home to office, how much time it is taking. Every day if you are recording that, that becomes a data point for you. Now there is some insight within that. If there is data, there is a behavior embedded in that. How can we extract that behavior? If we can understand that behavior, then we can model it. So a very simple example of, let's take distance and time. I'm starting from home, at 8 o'clock, I'm reaching office 8:35. So I'll collect this data for last 30 days. Then I'll build a model here that if I start at this time, how much time it will take for me to reach office. So if somebody will ask a question on an average, how much time you will need to reach office? You will say that, okay, 30 minutes. Given that the scenarios would be, could be the traffic, could be a public holiday, could be some other due to some chaos, some strikes. So these are factors. If I leverage those factors, I can correct my prediction that how much time it will take me to reach office. This is a very simple use case of the regression problems. That's called linear regression problem. Okay, so that means here, if there is no data, of course, you can't model it. You can't predict the behavior. Somebody has to track. Now who is that somebody? Maybe Ola app or Uber app that stores your journey from your home to office. Every day you are taking a cab. Now start time, end time, you have everyday data. If you extract that 30 days data, you will create a model out of it. You will find variations. On this day, Monday I started 8 o'clock. Tuesday I started 8:05. Thursday 8:10, 8:20. Like, so every day, if you have the data points, then you can model it. Once you model it, you can predict it. If you can predict it, you can take better decisions. So you will find unique patterns here. What are the unique patterns? It could be like every Monday, it is taking 35 to 45 minutes to reach office. If it is Friday, it's taking 20 minutes to reach office. If it's Wednesday and Thursday, it is taking 15 minutes. And this pattern is repeating every week. So there is a seasonal element in this. If you have data points, you can compare. Every Monday you can see it's around 40 plus minutes. Every Friday it's 25 minutes, like this. So if you have data, you can look for patterns. If there is a pattern, that can be modeled. If you can model it, you can predict it. If you can predict it, you can make it action, right? Action would be, I'll take, okay, on an average, I know how much time it will take. Oh, today is Monday, okay, I have to leave early, because it will definitely take 40 plus minutes for me, right? So that's how you can embed data science in your day-to-day activities as well. I'll give you a few more examples on how predictive models, data science can be embedded in our day-to-day life. Now, the previous slide, I was talking about data science. So it is a science of extracting insights from data. Insights should be actionable, otherwise there is no point. If I know that there is something happening every, like there is a particular time interval, something is happening repeatedly. But what should I do with that? I mean, with that, right? Can I do something? Can I take some actions? Can I perform something? How do I remove or how do I mitigate that problem if that is a problem, right? Yeah. So, to understand the data science process, so there are like various steps here. So the first step would be, I think it's not legible. Fine. So like various things here. I'll break it down into 4 major components. The first major component is data. Data available, not available. Like in the previous example I was talking about, starting from home, reaching office. If we think, oh, we don't have data. No, there is data. You have to identify where it is. Now you have to go to either Ola app or Uber app to find out, yes, I have the recorded data here, right? That's one. Second, when I say, like, again, same problem from city to airport, if I compute the time, right? So at an aggregate level, if Ola can analyze this, how many cabs I will need by different time slots, morning 7 to 12, afternoon 12 to maybe 5, then 5 to midnight, and midnight to morning, early morning. They can block like 4 different blocks. How many cabs I need morning time, how many cabs I need this time, how many cabs I need this time. If they want to understand the number of cabs will be required at different time slots, they can realign itself. Customer don't have to pay this surge pricing. Next part is processing. The processing could be based on some queries, like looking at some criteria. Maybe by this pin code I want to see top 5 orders, top 5 people who are ordering the or availing the cabs, etc. Right? So this is about processing. So processing has the visualization layer embedded in that. What is visualization? Again, if I represent the numbers as it is to the user, may not be meaningful. The user forgets the numbers, whether it is 1.5 or 1.7 or 1.75 or 5.7 confusion. The user will always forget things. The numbers are very confusing. But I represented 2 bars. This is 1.7, this is 1.57. So there is a difference. If I represent it in a bar chart, the user will always remember that, okay, this is greater than this. But he will not be able to remember the numbers, the decimal points. But he can remember the graph. So visualization is very powerful. Now after visualization, if it is a case of anything prediction or classification, then I'll go for model building. But if model building is not required, that's fine. I'll just end up with the visualization layer. That's kind of like giving reporting requirements. You have 2 terabytes of data. Now you want to just represent graphically what it is there by creating different cuts, different filters you have to use, and different nice visualizations like bubble chart, then geo mapping, line chart, graph chart, etc. Various graphs and charts. But if you have a prediction or classification requirement, so the data scientist's role is to fit a data to a model and look for patterns. Pattern recognition is very important. It's very important. Like even if normal data points you have to understand if there is a data, there is underlying a distribution from where the data is getting generated. Again, I'm relating back to that previous example of leaving home 8 o'clock, reaching office 8:35. Right? So here there is a pattern. There is some behavior embedded in that. And this data point, when you represent it in an Excel sheet, you will find that it resembles to some statistical distributions. So every data generation process is getting or mapped to any particular statistical distributions. There are various statistical distributions. You just have to see what type of data and which type of distribution it is fitting to, right? So understanding the statistics distribution part of it and how the statistical distribution is resembling to the way the data is getting generated. If you can fit in to that, you can predict things. You can predict the probability. You can predict the occurrence. You can predict what is likely to happen. Fine? So every data generation process or every step in the data science process is predictable, provided you know the underlying pattern. You know the underlying structure from where the data is getting generated. Fine. So keeping that in mind, so there are three things here: math and statistics, computer science, and domain expertise. These are the three different domain areas. Conjecture of is this resides your data science. What does that mean and why computer science? If I'm not from computer science background, okay, how do I learn this? Right? Nothing to worry. Now, first focus on your domain. Whichever domain, whichever area you are currently working on, get mastery over that quickly. That's the starting point. Suppose I'm working in the insurance domain. My job is, let's take, I'm a processing guy. I get forms from the field. My job is data entry. I look at the form and I do a computer entry here. Simple job, right? But still I can do this. How? Because I have to get this mastery. What is the mastery component here? The mastery component here is, can I scan this form? And I will have the OCR reader to recognize the handwritten patterns versus the printed patterns. Handwritten is a human element, printed is computer generated. If I can classify both, I'll take the handwritten elements, I'll have the simple replica here also digitally, I'll get the values populated there in the filter itself. So I don't have to type it. I get the form, scan it, get the scanner, load the scanned image. The image is automatically getting translated to a form. The form is translated to Excel spreadsheet. Now, how do I do that? Because I don't know programming. How do I do that? I don't have to know the basics of the programming. I have to know how to use it, right? So, what does that mean? I just have to write some import procedures in Python, right? There are some external libraries available. You don't have to know the exact nuances how the computer science in the background it works. I'm the user. I'm not the developer. I'm not going to develop the Python library. I'm the user of Python library. I'll simply call this process from this library. This is my input image, parse it, and store it. That's it. So you are automating this entire process. You are still a data entry operator, but your job role is now enhanced through data science. So how you are, yeah please. So how you are enhancing your role or glorifying yourself, still your job is a data entry operator, but I'm doing a now much better job. Now here my job role would be just supervise. Scanned, uploaded, Excel sheet, I have to just verify a couple of numbers if the machine is correctly scanning it or not. Wherever there is a break, I just have to correct it manually. So, as a data entry operator, let's take 200 forms I used to enter in a system. Now I could enter 2000 forms a day. I can churn out more numbers. So it increases my efficiency, it increases my skill sets, it increases my productivity as well. Right? So that's why I'm saying start with your domain. So whichever domain you are currently, think of how I can bring automation to that, how I can change that. Okay, that's how the domain expertise. Next comes math and stats. Mathematics and statistics is required. High level math stats not required. Up to 10th or 12th class mathematics is required, not beyond that. High level statistics, mathematics, not absolutely required. When I'm saying 12th class, so like if you just cover the linear algebra after 12th class, that is more than sufficient. That is the math required. Advanced math not at all required. Initial. Only 2 chapters or 3 chapters of linear algebra, if you could finish, that's more than sufficient. That's the math part of it. Stats, same thing. If you just look at the NCERT textbook of stats, that's more than sufficient. You don't need high level stats or maths. If you want to know, okay, I want to compute the probability density function of so and so distribution with these parameters, that parameters, why do I have to know that equation? Not required, because there is a computer program that will help us. I should be only knowing that this is a distribution, it accepts 3 parameters and it gives a probability to me. How it works, how it estimates using this maximum likelihood estimation method, what is maximum likelihood estimation, what is central limit theorem. I am not a researcher into PhD or somebody into statistics, right? That's why you have to always think as a user, and that is the starting point. That's how you will start the journey in data science. Then you dig deeper and understand more. If this is the same distribution, input data set remains same, and I'm passing those 3 parameters, every time I run it, I should be getting the similar probability or equal probability. But if I'm not getting equal probability, there is something wrong. Then I have to go back and check the equation. What happened? Why I'm not getting the equal probability? Input data same, parameters are same, but I should get the output also same, right? So then you will get little deeper into understanding the math and stats part of it. Initially, not required, absolutely not required. Now, the third aspect is basically computer science. So start with the basic programming. Basic programming in the sense like you have to know all the libraries, what are the extensions or libraries available, and those libraries are over time becoming so user friendly that you don't have to know complex programs. It's very, very flexible. So each syntax will accept some parameters. And what are those parameters? What are the acceptable parameters in those arguments? It is already specified. It will say that, okay, this is LM is a function. Within that, it accepts 3 parameters. Complexity parameter, number of jobs to run, and probably like a copy of X or true, or intercept equal to true or false. 3 parameters. And you know the acceptable values in those parameters. You play around only those acceptable values. That's it. So play with basic set of programs and play with the basic set of the arguments. That's the starting point. Then once you play with that, you will get hands-on. You can extend to maybe logistic, maybe random forest, maybe decision tree, then gradually. So this will be like day 2, day 3, day 4, day 5. So I'll move on to different algorithms, understand their background, like how it works, etc. That's how, when you say, like when you want to implement some algo, you have to first understand, is there a corresponding function in Python or R or any other software language where it can be stored. Fine. So that's why you need 3 things in data science. So whichever field, suppose I'm from math and stats background, I'll move math and stats dimension. I'll get mastery over all the concepts that I have learned in my graduation or post-graduation days. Get mastery quickly, brush up all your notes and textbooks, etc. Now that's your domain. Then you get mastery over the computer programs, the syntaxes, libraries, how it works, etc. Once you get mastery over that, then look at the domain. That would be the least priority for you. But if you are from domain expert, you first get mastery over your domain, then whichever is easier for you. If math and stats is easier, go this way. Then go to computer programs. If you are a programmer, then start with programming background, get the statistical concepts, then go to the domain experts. Okay? So that should be the journey. And looking at the statistics part of it, so statistics is basically a function. It's nothing else, it's just a function. How do you create that function? And why things are changing now? Earlier it was there in statistical modeling as well. Traditionally what we used to do is, we have input data set, we have a modeling framework. We'll try to fit the data to modeling framework. That's what the things has been so far, right? Like in logistic regression, so you have a modeling framework. You know this is my equation. You have input data and you are trying to fit the data to the model. Okay, I'm not able to fit, go back, do some transformations, change some columns, then try to fit it once again. Again, I'm not able to fit. So this process is very iterative. What is changing now? We are asking algo to learn from data. We are not fixing a modeling framework here. We are not telling the model, we are not telling the data that this is a model you have to fit in. I'm telling the data to go and search whatever function. So model is basically a function. You go and search, find out the best function and identify the parameters to reach to the output. Any modeling framework.
Why you have introduced the error there in the random error?
I'll come to that. So any statistical modeling framework or any predictive modeling framework, it has three things: input, output, and there is a function. That function is the behavior of input data in performing the output. Fine? So you have input data, you have expected output, you want this output from this input data. Now how to reach from input to output? You are taking the help of the function. Okay? In traditional statistics, you used to fit this data to this function. The function was fixed. In machine learning, the function is not fixed. There are thousands of functions. You don't know which function will approximate best to the data. Right? So in statistics, what you used to do, function is fixed, one function only. Input, function, output. This is your predicted output. You have actual output. The difference between actual and prediction is basically your error. So if I'm predicting, okay, so it will take 20 minutes to reach office today, but it actually takes 25 minutes, the error is 5. Either your prediction will exceed the actual or it will be shortage of your actual. Right? So that's your error term. So basically in statistical modeling, you were looking at input data, one function and one output, you are computing error. But in machine learning, you have input data, but there is no fixed function. Thousands of functions are there. You probably take all the functions, compute the error. Whichever function is giving you minimum error, you find out that model as the best model. So human iteration is now reduced. Machine iteration now increased. Your machine now takes, okay, I have to compute 1,000 models here. I'm not looking at only one function, right? I want to select the best model out of this. So 1,000 models, select the best model and identify the best model. Fine. Now coming back to the programming languages. So in programming languages, there are two leading languages, R and Python. Python is, again, it is leading in comparison to R. Why? Because it's quite flexible. And the flexibility is because of three reasons. One, it is compatible with other languages like Java, Django integration you can do. And it is also compatible with like many programmers. It is compatible with the big data environment. You can write the Spark APIs also using Python. That's why integration wise it is quite flexible. Second important reason why it is flexible is that API creations. When you are integrating a machine learning model in the application, maybe Android application, web application, or maybe like some kind of interfaces or IoT devices, The IoT devices, it will accept the parameters, it will perform some task, it will give predictions or classifications. While building the automated or systems or automated machines, you want quicker processing. In that case, there is no human intervention here. Input JSON will come, your program should read that as an input, whatever preprocess you want to do the preprocess, it will generate the predictions in JSON format, represent it in the graph or chart, or maybe give it to the user as an output. There is no human intervention, and this has to be automated through an API. The API creation is quite flexible. And last but not the least, all the scientific computations. If you have to compute a partial derivative of an equation, or maybe total differential equations, it's very difficult in other languages. In Java, you might have to write 200 lines of code. In Python, it's just 2 lines. So that's why it's quite flexible. A lot of library support, user support also you will get. Hence, it is very, very powerful. Versus R, R is quite user friendly. Python, initially you have to put some effort to understand the basic syntaxes and all. Not necessary to know how in the backend it works, but only from usage perspective, you just have to get acquainted with the syntaxes and all. If you look at R, R is quite easy. It's very, very user friendly. When it comes to scalability, R is not that powerful. Right? So, but another confusion in R is there are around 12,000 libraries. Who will remember all those 12,000 libraries? If you look at k-means, a clustering algo, this is available in 3 different libraries. Which one should I select? It's confusing. But in Python, it is quite standardized. You have at least 10 libraries you know, good enough. Machine learning, only 1 library. K means only 1 function. So Python is quite standardized. If you look at R, it's user friendly, and at times it is confusing because you have to search like which library, where it is present, etc. You have to search for that. Now, this is about small data. If I have a small spreadsheet or small maybe Excel sheet, how do I perform analysis? Now, if the data size increases, how do I do it? If data size is 2 GB around, I can't do analysis here on the single laptop. Then I have to search for the big data technologies. What are those big data technologies? I have to understand first like how it works. If it is open source, maybe Hadoop or Spark. Why Hadoop? Why Spark? First I have to understand the basics of Hadoop. So when you want to understand the basics of Hadoop, it's not from the developer perspective. You have to understand from the user perspective. How do I interact with the system? It's not like how do I configure a Hadoop ecosystem? How do I create a Hadoop cluster on probably AWS or Google Cloud? It's about how do I use it? I have 2 GB of data. I should be able to push this data to a Hadoop. I should be able to extract the data. As a user, you have to interact with the Hadoop system. How do I do that? So then I have to learn the user side of Hadoop. If you turn like the developer side of Hadoop, you will be like little confused here. Like you have to understand all the technicalities of it. Cluster creation, cluster management, data migration, data shifting. So all those issues would be there. Fine. So then you have to understand the usage of Hadoop. How do I store 2 GB of data in a Hadoop cluster? Then what else? I have pushed the data to Hadoop. How do I use it? I should be having some retrieval mechanism here. Should I use Kafka? Should I use any other processor? How do I extract the data? Should I use Pig, Hive? How do I extract the data? Right? And if the data requires some kind of computation, maybe linear regression, maybe simple arithmetic mean of all the columns, how do I perform computation? To perform computation, I need a distributed computing platform because my storage is in distributed state. Right? So to perform, I need distributed computing platform. And your distributed computing platform is Spark. Now you need to know Spark. Okay? Now when I say knowing Spark, you don't have to know the basics, like how the Spark thing works, etc. You should be knowing from the user side itself, like if I write a Spark program using Python or R, how it works, how the distribution, so little bit about things. That's the starting point. Now when I'm saying that you don't have to know the basics how the Spark work, time being, right now. Once you get a grip of the basic understanding how it works, then you can dig deeper. How exactly this works, how the computation happens. Then your understanding will be in a delta mode. It's an incremental mode. Day one, you won't be able to cover everything. Always you should be in a state of mind of delta. Always look for the delta. Compete yourself every day. That today I know Spark's 5 functions, tomorrow I should be knowing 10 functions. Day after I should be knowing another 10 functions. So what those functions do, what are the usages? Simply, to do experiment, you need input data, you need to do some activity or some task, and you need to experiment around the functions. Play around the functions, get the input data, and try to perform something. You'll be able to understand like what happens, like how things are moving. Okay? So that's how the big data technologies play a very important role. Now the two leading softwares, open source softwares, Hadoop and Spark. So you'll find a lot of like other tools and technologies associated with Hadoop. So tools like Pig, Hive, then Scoop, Flume, so many things. Now there are different pipelines and protocols. Suppose I want to push, let's take a streaming data. There are different variants of data. Structured, unstructured, semi-structured, text, audio, video, streaming, IoT, sensor, geolocations. These are all different data types. Now if I have to push streaming data to Hadoop, how do I do that? Streaming is real time, like Twitter feeds, like video streaming. How many users that are currently watching this YouTube video? That data is always running. It's a running pipeline. I can't just break the pipeline, build something and plug it in. This is difficult. I have to just redirect the pipe, and before that my downstream should be ready. If it is not, it will break. So you have to build first your downstream, then you have to get this streaming data. So streaming data, then you have a special tool. Scoop, structured data. Flume, streaming data. So use those tools to push the data to Hadoop system. Now if it is text file, should I keep it as it is format, or should I process it and store it? These kind of decisions will come to your mind. Somebody is giving, okay, I have, let's take 2000 books in hard copy format. You have to store it. Should I scan it, upload it, parse it, and store it as a table? Or should I only scan it and just store the images? Storing is not the purpose. The purpose is reusability. Whatever I'm storing, I should be able to extract, make sense of it, and I should be able to monetize that in future. If future monetization is not possible, there is no point in storing the data. Huge data points I'm taking and I'm storing, I'm getting billed for that. If I'm storing it in cloud or Google Cloud or AWS, I'm paying something for the data storage itself. But if I'm not able to monetize that, there is no point in storing. So while storing, you have to think what information I'm storing here. Right? So text should be processed and stored as structured files versus text should be stored as it is. What is the best way to do that? Right? Now, if I process it, store it as a structured file, then how do I analyze? I can't just look at single tokens and do analysis. There has to be a construct behind it. Then I have to create something called IDF, inverse document frequency matrix. So that would be a large JSON file. Your document ID will be the key, the values would be the text. So we'll store it in key value pair format. Now where do you want to store it? I can't store it in SQL databases. I have to go for Elasticsearch for that. Right? So these are the things that will come to your minds when you are storing large amounts of data in Hadoop databases. Now then comes your Spark. How do I use Spark functions to retrieve the data? So the visualization comes into picture when you don't want to do some statistical modeling or something. You just want to print some reports, management reports. Every weekend you have to prepare some slides. You have to send it to the management. What is the performance over this week? Or maybe monthly reports. So there are different frequency of reports. Daily, weekly, monthly, quarterly. So, I mean, the management has to send to the senior management. Senior management has to send to the CEO. So there is a hierarchy to that. You can't send the data. 2 GB of data, I can't send it to my CEO. I have to send it through some visualizations. Now what is the best way to see it? If I'm taking 2 bars, y-axis and secondary y-axis, one is in percentage, one is in count. That's not a right visualization. Then comes to my mind like what is the best visualization way? What is the x, what is the y, what is the y2, and how do I represent it graphically? Whether to choose a pie chart or a bar chart or a clustered chart, what kind of charts I'll be deciding or choosing. Then comes to your mind Tableau. How can I quickly create some visualizations, graphs and charts? But my data is in 2 GB. I can't take it to a single machine. How do I create Tableau visualization with that? Right? Now can Tableau sit on top of Hadoop? Can Tableau read the HDFS file? Yes, of course yes. So Tableau is also providing the reading functionality from HDFS directly. Okay? So data visualization, that's why plays a very important role. Then comes the machine learning. Why machine learning? Because there is no time to respond as a human being to any particular event. As in, there is a fraudulent transaction happening. Your debit card or credit card is getting swiped. Now instantly you are getting a call. How the machine predicts that this could be a fraudulent transaction? Because your machine predicts that it's a fraudulent transaction. You are getting a call to validate, authorize that transaction. So there is a predictive model sits behind this. Okay? Now that's your machine learning. What was happening 2 years back or 5 years back? You had a fraudulent transaction. Until and unless you report it to the bank, nobody will get to know what happened. You first report, the bank will take a note of it, inform the backend team, they will find out the data point, do the investigation. The bank will tell you it will take 45 days to identify whether it is a fraudulent transaction or not. If it is a fraudulent transaction, then the bank will reverse the amount. Otherwise, no. But the turnaround time was 45 days. And now, even before passing this transaction, you are getting intimation. You have to validate whether it is good or bad transaction. Right? That's the power of a machine learning. Okay? Now, how it helps, you have seen now. This is in production now. Currently it is in production. Right? Now there are so many machine learning layers in different applications that we use today. We use Uber app, we use Ola app. All the applications that we use, or all the devices that we use, at least there are 5+ applications that uses AI and machine learning to improve the user experience, to get best services to us, and it helps us like spend less time on the application. It helps us identify what I'm looking for. Right? So now, how the machine learning thing works here? Let's take you open the Swiggy app. What you will do first? Or Zomato app. What you will do first? So every user has a journey. So you open, you just type the hotel name. This is one behavior. There is another behavior. You go to the menu, you search restaurants. First to apply filters. I want in Kormangla, I want this time. So that could be your criteria. So there are two different kinds of users. One user is very sure that where he is going. He is very sure that what he is looking for. The other is in exploratory mode. So there are two kinds of users. Now you have to differentiate those two behaviors from data wise. Now the machine understands that your behavior is more or less similar to this set of behaviors. The activities they did, you may would like to see that, or you may would like to do that. Then automatic recommendations will start pouring in your account, because there is a similarity in behavior. So the machine understands the behaviors and then it starts recommending things to you based on your similarity with your group of users. Fine? So, and always the machine is trying to understand unique behaviors from data, unique patterns from data. Amazon search, right? So when we do search, product search, there are very unique patterns, different unique patterns. Somebody will just type Google search, Amazon.in. Somebody will type in the browser itself, Amazon.in. Somebody will do Amazon, get the Amazon.com, Amazon, let's take IN, CN, SN, AU, etc. and you click on some other link and you will go there. So there are different journeys, different paths, and each path is unique. And each set or each path can be modeled. So in a machine learning system, there are three things: performance, then task, and experience. If the performance of any computer program or if the performance of any system, it improves over time by receiving more data points, more examples, more experiments relating to a task, and if the performance improves, then that is a perfect example of machine learning. Right? So I'll break down it into three components: performance, task, and experience. Performance relating to what? I have to identify the task. What is the task? If the task is to separate goods from the bads, if the task is to predict something, if the task is to classify, group them together, if the task is to recommend to the user what is likely to happen. So the task can be broken down into like 4 or 5 different areas. It could be forecasting, it could be grouping, clustering, prediction, classification, anything. You have to break down what is the task, because your performance depends on what task it is. Then you have to evaluate whether it is good or bad. So if it is a classification, you will be looking at AUC or ROC. In statistics, it's called area under the curve or receiver operating characteristic curve to find out the accuracy. If it is prediction, you have to look at the mean square error. How many times I am getting the error and what is the average of it. If it is forecasting, you will be looking at MAP, mean absolute percentage error. So each task, you have a different set of accuracy parameters. Now if your accuracy improves, then it performs really well. If your accuracy goes down, my performance criteria is not meeting. So first you set up your performance criteria relating to a particular task. And before that you have to define what task it is. Define the task, set the performance criteria, and you have to say that what is the delta. If it is going down, retain the current state. If it is going back or if it improves, go to the next state. That's how you will set the performance criteria. So setting up the performance criteria, looking at the task, that sets up your ground for machine learning. Then the last is E, which is experience or examples. Basic model is ready on an input data set. Now you feed more data. Get more examples, more experiences, more experiments, that is samples. Get more samples, feed to the same data point here, input data, rerun the model, and see if your accuracy is improving relating to that particular task. Now this becomes a perfect machine learning system. Okay? So setting up the parameters, identifying the best parameters criteria, and then optimizing it. The last step is basically optimization, where you will stop. Should this process keep continuing, or there is any criteria where you should stop this, right? So you feed more and more data to get a stable result. Once it is getting stabilized at some point, fix it there, get the best parameters, and represent it as a final model. Done. Once it is done, get the values and use it as a prediction service. Now this is your training part. This is not the prediction part, or this is not the test part. Once it is done, get the object and do a prediction or classification, which is for deployment purpose. That's how you will deploy a machine learning model. So training is separate, deployment is separate. Okay, any questions on this? Yeah.
Suppose according to the time frame, you are getting huge millions of data.
Correct. Records or columns?
Sorry?
Millions of records or millions of columns?
Records.
Records, correct.
So it's a huge data. Now suppose you are using a cloud or any service, say AWS or Azure. So don't you think feeding all that data in particular, you're dumping that platform, or maybe it is a platform as a service, any cloud.
Correct.
So feeding everything to that cloud wouldn't be expensive.
It is. It is expensive.
So can't we have a local computation or something?
Correct. So for that, like if it is a classification problem, that is called localization shift balancing.
So can we just push the delta part into the cloud and manage this?
No, this is million records means all data, right?
Sorry?
You have million records means all million data points.
Yeah.
You have to pass the entire data point
Is it
to the model.
required or?
It is required. It is required. Now I'm telling you the way to handle it. If you push all the million records and you will perform a large computation here, so linear regression, it will be a matrix computation, which will take huge memory space, right? So to address this, what you can do is, it's a sampling approach. So you have a class, let's take 1 and 2, you want to predict. Default 1, no default 0. You want to predict or classify something. Now take a local shift balance, which is basically shuffle the data, take 20% for ones, 20% for zeros, train a model, like get the parameters. No, in cloud only. Take it to the cloud, but you are taking 20% of ones and zeros and training a model. Now shuffle the data, then pick up another 20%, do a batch mode. Instead of performing large computations, sequentially perform it, or when you convert it to a batch problem, you can do a Spark also, like distributed computing. At the same go, you are not pushing all the million records, you are probably taking 20 samples of 20% each from zeros and ones, combine them together, give it to the algo. Perform the computation parallelly. So 20%, 20 times you are doing this activity rather than sending all 2 million records.
Is it not possible that we do something locally and then just send the delta part to the cloud?
It is possible, but you have to do a sampling. Now sampling should be representative of the population. If it is biased, suppose you pull, let's take first 200 records or 2000 records, you build a model, the remaining you have not seen the data. What if there is something in that you don't know? That's a problem. Now when you take a random sampling, this is called stratified random sampling. Your strata is dictated by the y variable. The y variable has zeros and ones. Based on that strata, you are keeping 80% and 20%, you can decide how many records you want to pull. Randomly do a stratified random sampling here, that's why I'm saying strata is y, then perform random sampling from each strata, combine this together, train the model, store the coefficients. Now do this in batch mode, 20 different iterations. When you take stratified random sampling, it doesn't matter where it is storing in the entire space, you are randomly covering it. Then you put it in the batch mode, and whichever module is giving best result, then combine it. Yeah.
Basically, we are not taking the whole population.
Yeah.
So we are not storing the whole population.
No. We are just storing the model object.
The samples.
Model object. So I'm taking the sample, passing it through the function, reaching the output. I'll store the model coefficients only. So that's why I'm storing the model object. Yeah?
Yeah, so when you're parallelly trying to develop the model as such, when you get very distinct coefficients among the different batches.
Correct. Correct.
So how do you approach it? How do you further?
You have to use cross-validations for that. So you can use like k-fold cross-validation, maybe 20-fold or 10-fold, depending on your sample size. So once you have done this stratified sampling, then on top of it, you will do a cross-validation. While doing cross-validation, you will use the grid search. So there is a module called extensive grid search to find out the best parameters. These will be the optimized parameters. When you use optimized parameters, whatever data variation would be there, it will definitely capture that. Okay? Yeah.
This is all part of neural networks, right?
Which one?
Whatever analysis we are doing, or it's statistics, completely statistics. Or
No, it's not only neural network. You can train anything. Any model you can train. It can be bagging, it can be boosting, it can be adaptive boosting, it can be regularized boosting, stochastic gradient boosting, extreme gradient boosting. There are different methods. You can use all parallelly. Yeah.
Yeah, you mentioned about classification and clustering. So normally
Correct.
these two terms. So
Fine.
example of classification versus clustering.
Correct. Yeah, I'll just give one example. So I'll give you one example from Australia. So what is happening there, like manpower shortage country. So they have large cucumber fields. Like the machines are plucking the cucumbers from large fields, and they have to segment it small, medium, large. So somebody has to classify that. But there is no tagging mechanism here. Somebody will tag, okay, this is small cucumber, this is large cucumber, this is medium cucumber. There is no human being there. Now here, if you don't know the criteria to classify it, that becomes your clustering, where you are just getting all the cucumbers. Now somebody is looking at the cucumbers and classifying them into 3 different buckets: small, medium, large. Then they will have like different pricing. Now thing is here, while getting those cucumbers, that is your clustering problem. The objective is to segment it into 3, right? Once this step is done, when it goes to the market, there is a tag. On the packet it is written, this is small cucumber. Now that becomes your classification, because somebody has already tagged it. Before tagging, it's clustering, because you don't know the criteria, how to classify small from medium, medium from large. You do not know. That's the example. It applies to all, like we do all those things in our day-to-day life also. So we used to do a lot of classifications, and there is no metric here. We are not measuring that what is the length, what is the breadth, what is the color of this cucumber so that it is small. We just use our heuristics. We look at the object, okay, this is small. Look at the object, this is medium. But post classification, if you want to do a measurement statistically, okay, what is the length, what is the weight, what is the breadth, what is the color of this cucumber, you represent it in Excel sheet. Now you have a tagging mechanism. This is small, this is medium, this is large. Now you can train one algo there. Now that becomes a classification problem.
Maybe you can say that unsupervised data will use clustering, and supervised data you have will do classification.
Correct. So unsupervised is always clustering. Supervised is always classification. Supervised means there is a level.
So
Okay.
what is graph processing in Spark?
Sorry?
What is graph processing in Spark? Graph processing.
Graph processing in Spark. Correct. So graph processing is basically, okay, I'll give you an example of a graph processing, like Facebook, LinkedIn, all the social networks. If you represent that data in a structured CSV file, it will be a huge structured CSV file. How many users are there in LinkedIn? 100 million plus. Now at best, one person can be connected to 20,000 people. LinkedIn has 30,000 limitation. If your follower exceeds 30,001, you have to create a different account. 30,000 is the limit. 100 million plus total users. If you represent it in a CSV file, how it will look like? User 1, row number 1, columns are other users, 100 million users. 20,000 it fills with value 1. This user connected to this user 1, else 0. Now look at rest of the items, all 0. If you collect all users data, so 100 million cross 100 million. Now look at the data sparsity. What is sparsity? So sparsity is basically non-value, like the null values. So 0 means this guy is not connected to rest of the people. These are all null. Large sparse matrix it will create. You cannot perform computation on that. It will consume a lot of memory. Instead of doing that, if I can create a network of it, one person connected to 10 people, 10 people connected to another 20 people. Now here, if somebody wants to do some computation on me, I'm connected to less than 10,000 people here. He doesn't have to search the entire 100 millions. So localized computation is possible. Now if you translate this data to a CSV format and perform computation, it is expensive. You want to keep it in graph format only, and still you want to do computation on graph itself. That's why you need graph processing.
But how we store that in database or something?
Graph database, it has different features. Graph is object. Now object will have, it's not a structured data, it's graph data. Graph data is object itself. Any other questions? Fine. So now domain expertise. How do you build domain expertise? Suppose I am from insurance background and I want to build a domain expertise in healthcare or maybe in aerospace engineering. How do I build domain expertise? That's a very good question. Sometimes people ask like, okay, I'm a fresher, I don't have any experience. How do I build domain expertise? And without domain expertise, can I start? Data science. Right? So what are the steps? To build, yeah.
Start from the beginning and understand various roles that are there in the domain. Also understand the business flows, understand the workflows.
Correct.
Understand business modeling.
Yeah.
Also understand what user does, different levels of user does.
Exactly.
Person who enters the data, person who uses the data, person who offers the data.
Exactly.
Understand the workflows.
Correct.
Understand master data, understand reports, understand transactions, understand queries.
Exactly. So if a person is starting like as a fresher, you first identify which domain interests you the most. Supply chain, logistics, banking, financial services. So which domain attracts you the most, or where you have some understanding, right? Then do extensive research. How to do research? Go to Google Scholar. So there is a tool, Google Scholar. Just type top 10 problems in supply chain management, top 10 problems in banking, top 10 problems in financial services. You'll get a list of research papers. That's the literature survey. First literature survey on a particular domain. So you are trying to find out the current burning problems in each domain. Then go back and do research in finding out the meaning of the terminologies that are used in those research papers. Then understand why it is a problem, if it is a problem in that domain. Okay? And what is the current practice of solving it? You'll also get from the research papers. Note down the current practice. If currently somebody is using neural network to solve it, but he's saying that okay, still I'm getting not very good accuracy, or the result is not satisfactory, then how can I improve it? Think about further changes to that. Now think innovation in that area. So you have to bring in innovation to the current practice. Now how to know the current practice? You have to do extensive patent search on Google Scholar. There are some patented research papers. There are some unpatented research papers as well. Go through the research papers, understand why it is a problem, if it is a problem. Now second, go to Quora.com. Q-U-O-R-A, Quora, where you'll find people asking questions, professionals asking questions, professionals also answering them. You identified 10 problems here, you put a question there. What is the best way to solve this problem? Then experts will start pouring their answers. Go through that. You say that, okay, I didn't understand this, help me this. Some more very clear understanding or examples will come in. They will also give valid links, URLs, PDF files, text documents. So they'll keep sending you the documents. Go through that. Get mastery over one problem. Now you have identified the domain here. Why it is a problem, what are the metrics, which metrics to track, how the metrics are related, how they are contributing to each other. Can I have a list of it? Top 10 problems, you have top 10 solutions. Then think about how can I apply math and stats or programming to solve it in a better way. Right? This will take time, but yes, person who is starting, he has to put in more efforts also in this. So you'll get good understanding about one domain, what are the current burning problems in that domain, and you would also get to know that how to solve it. Yeah.
Yeah, this will help in career growth. This will
Correct.
The domain expertise will help more in the career growth, because then it will be more specific. Or the technology understanding is helping you more in the career growth. What helps more?
Both required. So technology will simplify the process.
Insurance will be approaching it more.
Yeah, so any domain. So technology will simplify the process. Technology will simplify the process. Let's take, I want to compute, I'll just give one example of SpaceX. So when they launched the first Falcon, so it crashed. While landing, it crashed. Then they did research why it crashed. Right? So then they found out the reason. Then there was a small mistake in the estimation of the arc. Small mistake, very small mistake that usually people make. And it is only 0.001 to 0.002. This need to be changed. Very small thing. So here the point is how to break down the issue, and here there is no advanced technology requirement. It just find out the reasons why it is breaking. Similarly, any domain, when I'm looking at a problem, first I need to understand why it is a problem here and how people are using it and solving it currently. Then I'll think of technology. If Python can help me, Hadoop can help me, Spark can help me, where Spark sits in this pipeline, how do I build the pipeline? So when you're thinking about a problem, any domain, think about a problem, then draw the process flow. This is a data step, this is a processing step, this is a model step, this is a technology step, this is a deployment step. Write down the major steps. Then in deployment, what do I need? I need one platform or UI, front end. There has to be a back end, there has to be a processor, there has to be a bunch of APIs. Then if it is a data step, where I will get the data, incoming data, is it streaming, is it structured file, is it coming from some other FTPs, where I'm getting data, where I'm dumping. So each step you will break it, like what is the input, what is the output. Break it this way. So this is about first structured thinking, defining the problem and designing the process flow. That is very important.
And also, there could be a business strategist who is more closer to develop.
I don't need jazzy applications or APIs, Python, Spark, etc. I don't need. So it's like understanding the customer need. So that's how the domain expertise comes into play. Now similarly, understanding the metrics as well. Now when you are looking at a new data set, you'll be curious to know that, okay, what is this metric? What does it do? I don't know. Like for example, IoT. In large hotel groups, how do they manage the infrastructure? Lighting system, cooling system, then server rooms, how do they manage those things? So there are sensors. So there are 3 different kinds of sensors. Temperature sensor, humidity sensor, lighting sensor. So it understands, the sensor understands, if there is a human being present in a room, it will change the infrared frequency. Now what is the delta? Delta changes in infrared frequency in a room if a human being present versus a dog present or a cat present. The delta will vary. Now the machine understands that if a human is not present in the room, switch off the light, switch off the AC automatically. Right? So similarly in the data centers as well. If there is no processing going on, why to switch on the cooling part? Switch it off. That's how the large scale infrastructure management companies, they are taking help of those sensors and machine learning to identify what action need to be taken. So in those cases, why I'm talking about this? Because metric important. What is the metric? Now in this case, metric is delta. The change in infrared frequency in a controlled environment if any outside object is present. You have to understand the delta part of it, the changes, the metric. Okay? Fine. So looking at this, steps for success in data science, so I have already spoken like how to proceed or how to start the journey. So first, understand the business, set goals. Understanding business means not necessary to understand everything, like suppose I'll talk about supply chain. Supply chain is a bigger area. You have to break the problem. You have to identify what are the smaller areas where I should focus on. Supply chain, logistics management, inventory management, out of stock management, route management, route optimization. There are various problems. So you figure out only one problem, then think how people are currently solving it. How do they solve? Is it the best way to solve? Can I apply any other techniques to improve it? Biggest problem is inventory management, out of stock management. How do they know, how do they predict that how many units they would need next 30 days? They should be able to get an idea how many units they are able to sell every day, how much they would need for next 30 days, next 15 days, next 1 week, so that they can keep sufficient stock. Their manufacturing units are 1 or 2 in the country. If you take example of Honda cars, their Mysore plant is Gurgaon. It's the biggest plant. It caters to almost like 80% of their requirement. A smaller plant in Chennai, which is like catering to only 1 or 2 states. Only one manufacturing unit. There are so many distribution centers, so many retailers. How do they optimize the route? They have a requirement 200 pieces from Hyderabad, 20 pieces in Bangalore. They have to come to Bangalore directly first, or they have to come to Hyderabad first. Volume is 200. But if he goes directly from Gurgaon to Hyderabad, then comes back to Bangalore, he has to travel a lot. Now he should come back to Bangalore first, drop 20, then go to Hyderabad. Who will decide that? Now this is just example of 3. One source location, there are 2 destinations. But if it is a n cross n, what is the best route? How do I identify that? Is there any algorithm to solve it? Correct. So how do you solve the transportation problem here? So can I use some kind of optimization techniques? Can I use some kind of linear optimization or non-linear optimization techniques here? If it is an optimization problem, I need objective function. I need some cost constraints, cost functions. I have to estimate the error also, loss function, minimize the loss or minimize the constraints, then maximize the objective function. So that's how you will just plan. So a problem is there. People do a lot of like manual things to solve it. Sometimes experience, past experience, they will use, okay, you go there, then go there, like this way. But is there any mathematical way of doing things which will give you best results? Certainly not right now. Now this can be improved further. Now what if, while this guy from Gurgaon coming to Bangalore, and there is a traffic or there is a strike going on the route, which could lead to like 2 days of delay. Now, can I get a real-time signal sending the driver the message that, okay, you go to Hyderabad first. By the time the strike gets over here, you can drop the vehicles here. Now, it's a real-time messaging system coordinating and optimizing the results, the performance. This guy doesn't have to sit there for 2 days just because there is a strike going on. He'll just divert to another location, drop it, use that time and drop it here. Right? So that's how like real-time messaging system and supply chain management on how do you manage this. This is one example. Then inventory example is also there. So like different industries, they have similar problems. A set of problems which is still unsolved. It is not solved yet. If it is solved, it's just like a jugaad. Many industries, they are still struggling with the old problem. Still, because there is some human element, they are not able to translate it to a mathematical element. That's why it is still there in like jugaad state. You get mathematically good results, but still you want to manipulate the results. No, I don't want to do this way, do this way. Right? So how do you ensure that they would also be used to a system where mathematics or statistics can still give you best results? And for that, you need to have domain knowledge. How do you translate this? You have to translate this output to a business language. And that is important. Okay? Now this I have already spoken. So like the machine learning has 3 different tasks: classification and supervised and unsupervised. Supervised is basically when you have labeled data. You have a target function, you have a labeled data, and you want to predict to reach to that prediction or that label, you are taking the help of a function. That function is applied on the input data set to produce that output. Now that's why it becomes a supervised problem. Okay? And unsupervised, where it's simply clustering. These are like few sample examples. So the list is not very limited like this. If you look at like support vector machines, so you can create 20 different support vector machines, 20 models you can create.
Can we simplify that? Unsupervised learning is a scheme where you just leave everything to model and model does everything for you.
Exactly.
And unsupervised learning is you have to interview.
No, unsupervised is where you do not know the
statistical model does everything and you just believe on that model.
Correct. So unsupervised is basically there is no y variable or dependent variable that you want to achieve. There is nothing you want to achieve here. You just want to see how things are placed. You just want to see. There is no supervised element here. There is no bucket here that this person should here sit here, this person should here sit here. No. There is no classification here. It's simply the groups.
What if kind of
Correct. So I'll explain that. Now in classification, you already know the labels. Like for example, I'll talk about, let's take a retailer's example. Now we get the messages, 20% discount, 30% discount, new collections, messages we get from, let's take shopping centers like Central, Big Bazaar, etc. we used to get. If they want to understand how many unique customer groups I have, there is no label. This customer is bad, this customer is good, this customer is very good. Nobody labels it. They just want to understand how many unique group of customers I have. Then it's a clustering problem. Here what will happen, similar users, I'll group them together. I'll find from the behavior itself and I'll group them together. So one behavior would be, every time I send a discount message, this guy comes in. Now how many such customers are there? Okay, 200 customers. Now this is my group 1. But good or bad, I don't know. I'm saying only group 1. Right? Now, there will be another group, every month, they're at least exploring, coming to my store, exploring, they're buying something. Maybe a shoes, maybe a t-shirt or something they are buying, at least one product, low value product, but they're buying something. So these are my frequent buyers. I'll group them together and I'll call them group 2. There is no label here. Then I'll search for non-responders. Whatsoever I do, they never comes back. These are my non-responders. I'll say that they are not responding. This is my group 3. Now I will find another group who are every month at least once they are visiting. Every time they visit, they make a shopping of $1,000 plus. So this is my premium group. But again, I'm not putting level. I'm saying group number 4. So if you want to understand like how many such unique groups exist in my entire customer database, it could be 20, it could be 50, it could be 60. Anything. There is no limit here. Hence, it is unsupervised. So it's about finding similarity in behavior and grouping them together. Clear? There is no supervised element here. Nobody is labeling them as good, bad, non-responders. It's simply the group 1, group 2, group 3, group 4 like this. However, in this case, if you turn this problem to a classification problem, now in the database you have a label, default, no default. There is a label in customer or credit card database. You'll find one credit card, this is default. One credit card, this is no default. The label is already there. And here you are trying to understand if it is labeled as default, what are the unique behaviors of default people, what are the unique behaviors of no default people. That becomes your classification or supervised problem.
So basically classification includes subgrouping. Do you mean this?
Correct. It's about subgrouping.
Under default 0 and 1 there are again subgrouping.
No, there you know the default, no default.
Okay.
If you apply the same thing, okay, minus that y variable, default, no default. And the similar x variables, if you apply clustering, the behavior might be similar, but you might be finding both 0 and 1 within a cluster. For example, always let's take 20 people, they use 80% of their credit limit every month over last 24 months. Like a group in clustering. But when I understand their behavior, 10 of them are defaulters. Rest 10 they are honest payers. Though they are using 90% of their credit limit every month, they are honest payers. So in clustering, you are looking at only attributes. Within that you find both. So
Maybe a difference in clustering.
correct.
And no difference in classification.
Correct. So here you are looking at the behavior. You are not looking at the response. You are looking at the similarity in behavior.
That's nothing but grouping kind of.
Sorry?
You are grouping something based on some behavior in the classification.
Correct. Now here it is already done by someone else.
See, nearest neighbor is, you assume that this person is like a neighbor. So the qualities of neighbor is attributed to this particular sample.
Correct.
Right? So you are just doing behavior analysis.
Characteristics also.
So this person is similar to neighbor. So he copies his characteristics.
Correct. So this is like looking at the attributes and similarity in attribute, put them in one bucket.
So it's a classification.
It's a clustering. It's not classification.
So it's not under that. See, if you look at your diagram, it's on the nearest neighbor is on.
No, nearest neighbor also you can use for classification, you can use for clustering.
Okay.
Both ways you can use.
Okay.
Okay. There are some algorithms like neural network, you can use across all. Across all you can use it. Similarly, you can use ensembles, decision tree. Ensembles also you can use across. Okay? Any questions? Clustering and classification is clear, right? Fine. So just assume that before labeling this, if somebody has done clustering and you are putting a label, that becomes a classification problem. Like small, medium, large cucumber example I have given. Once you have done the classification and you have passed this data set to someone, for him it is a classification problem. For the person who was doing this, it is an unsupervised problem or clustering problem. Once it is done, the labeling is done, then it's a supervised problem. So labeling is one activity. In all machine learning literature, labeling is one activity. Who will be labeling that? This is just step. Right? So for example, like the articles that you are seeing in the news feed, politics, business, sports, technology, health, film, television, etc. You are getting classified news feeds. Who is doing that classification? If you go back to the initial stages of Google News, it was random. Somebody has to tag it. Now, there is a tagging mechanism, there was a tagging mechanism, and the machine is being trained on top of that. Now we are seeing classified examples or classified articles. So, first unsupervised, create tagging, then turn it to a classification algorithm, then you will be able to classify or further process it. Clear? Yeah? Fine. So these are all like possible job scenarios in data science. It's self-explanatory, no need to explain this. If you have any questions, you can ask me. Not limited to this list, there could be intermediate roles as well. Like
certifications,
sorry?
Are there any industry recognized certifications for each of these levels?
Certifications? Yeah. How certifications play a role?
For example, network, Cisco certified network analyst.
So yeah, it's at a very preliminary stage now.
Certifications are not there.
Certifications, like there is no industry standard or ISO kind of thing, because that,
see, for example,
even for individuals also, like
certified Java program.
Because the Sun microsystem is certifying now, because they have expertise in that. Now in data science, it's a very like early stage domain now. So it's just like maybe 7-8 years or 10 years, the data science domain. That is Hadoop only. That is Hadoop certified only. So data science, it's a combination of various tools. So there is no parent organization that provides data science as such certification. So there are like course completion certifications you will get. Once you perform a course, you are undergone a structured training program under a specified trainer. So you will get a certification saying that you are certified for this particular course, successfully completing this particular course. But like industry certification thing, it is too early. So it will take maybe another some years to have a like international body who recognizes and gives certifications. Right now there is no, because it's still evolving. The data science, the scope is not limited. It's now getting extended to any domain. So it will take time to achieve this.
So this data, if at all I get into this science thing, whatever. So will I be able to secure my job? Like, is there a guarantee? Is there a guarantee? Because I've seen companies in US wherein you can see in Wall Street. So there's a company which was built on, it's called Kensho. So there were like 400 people working. Like their salaries range from $350,000 to $5 lakh. So now there are just 2 people working there. So can you just imagine, because it's built on algorithms, like whatever you're saying, machine learning, they've actually done it. So is it a guarantee people like us, if you're saying this is in a nascent stage today. So today, okay, for next 2-3 years, maybe I'll be able to get a job. So but after that, what happens? Like 400, where is 400 people and where is like just 2? So tomorrow I'll be thrown out of the organization. So what do you think about it?
See, it's about your innovation. How do you sell yourself and what problems you can solve? That is important.
No, but if you look at the same thing, Amazon is the biggest sales company. So they don't have a sales team sitting right there.
Correct.
So it's all algorithms.
Correct.
Okay.
Correct.
So but you just have a customer support executives, so that can also be easily automated. IVR systems done, that's all. So
correct.
You build a prototype or something object, so it can be automated. So you're trying to minimize the human element, wherein you are completely thrown out the next day.
Yes.
So, but where would I go and actually find another job? That's
correct. So that's why, like, we are in a state of like continuous learning now. You have to learn the next thing.
So there's no guarantee.
Yeah, there is no guarantee. There is like, it's like things are becoming redundant every day. You have to learn the new thing to go to the next level. There is no other way. So learning is the only key now. As you learn more and more techniques, and you will grow faster. Like that algorithmic trading company you are saying, like 2 people they're managing, but you know, like the database people, 200 people are there to manage the database. So basically earlier there were like 20 people to manage the database. Now they have 200 people to manage the database. Why? Because they need Hadoop and Spark professionals, because the data size is also increasing every day. So they have to take care of their clusters, nodes, processing, backup, transition, migrations, update, everything. They need more people in some area. They cut down some people in some area. So there is still opportunity in other area. So opportunities will be there in somewhere, in some state. You have to just find out like where it is. And for that, what skill set is required? You quickly get the skill set and move. No degree, no certification, no background, nothing required. It's simply how quickly you can learn and deploy a prototype. Go ahead. Clear? Yeah.
Is there any differentiation between those jobs? Like, I've done data visualization, Tableau, Power BI, and I've learned machine learning as well. So should I go as a data analyst or a data scientist?
Correct. Now, there is no strict differentiation between the roles here, as far as like organizations are concerned. Like different organizations, if you are in a startup, so you probably have to do all those tasks as a single person. You are a business analyst, you are a data analyst, you are also a data visualization expert, you are a statistician, you are a machine learning expert, you are also a data scientist. Because you are doing end-to-end, everything. You get the data, you talk to the client, get the requirement, then understand the problem, you translate it to a problem statement, building a model, creating visualizations, dashboards, you send it, then you build a prototype, model, deploy, give it to the IT team for deployment. So entire stuff you are doing. One-man army, right? Versus organizations like they have like data migration team. From some other server, some cloud, they will simply migrate the data to some other team, their job is done. Now, data cleaning team. They'll remove some criteria, validations they will apply, they'll clean it up, their job is done. So it's really difficult to say that which role spills over to each other role. Sometimes someone has to perform multiple roles. Somehow someone has to perform like individual or compartmentalized roles. But there is no strict differentiation. No, you can't do data science. Absolutely you can do that. There is no hard and fast rule that, okay, I'm a business analyst, I can't do this. No. You can do all the tasks. If you're in a startup environment, you will change completely. You have to do everything. Right?
For someone from IT infra background, like storage and backups and computing, cloud computing, so how much suitable is data science? Like, is it a good transition?
So I would...
Next career level transition?
Correct. So I will say that data science is as such, it's not a field. It's a practice which you can take it to your field. Suppose you are saying like infrastructure, security management, etc. And I would say data science is something which is now highest usage is in security management. Servers, security management, and the infrastructure management, it is the most used domain now. Why? Because you have always a supervised element in your network security and I mean in your domain, you have always a supervised element. You don't have an unsupervised element because there is each action, it has a resulting response and you have a data stored somewhere. You have log files, daily log files. Some activity is happening, whether it is a success or failure. If it is a failure, why it failed? Someone has to look at the log file. Now what is the response time to look at the error to figure out why it failed? Could be 2 days. I don't know. You have to tell me like what is the time, the response time. right? It could be 7 days also to figure out what happened, why it failed. Now, can I have a machine learning algo to tell me quickly where it failed and why it failed? Can I model it? Why every month this error I am getting? What is wrong? And is there any pattern in it? Every month on this specific day, at this specific time, morning, evening or night, I am getting this error. Why? What is happening? Now, can I translate back and see the features? Right? So, every software program, it has 3 stages. It must be receiving input from some state. It must be giving some output to the next processing. There must be some intermediary process. So, break can happen in 3 stages. Either input is not proper, input not received, input received partially, or if input received properly, then where it is breaking? Is it processing? What are the processes I am doing? What are the algos I am doing here? Maybe addition, deletion, subtraction, multiplication, whatever I am doing. Is it breaking at a process level? Or is it happening at a rendering level? I am rendering the output some other application. Is that application receiving my inputs? Is that API receiving my inputs? Where it is breaking? It must be breaking in 3 different stages. Now once I know that, okay, input stage, I'll put a log file here itself. The main log file, break it, put it at an input stage, put it at processing stage and output stage. So that's how you will break it down further to understand quickly where it is breaking. Right? So you can take this practice to your current domain. It's not like moving to this domain. So it's like, so here you know the machine learning now, and you know the language now, you know the statistics now. Now can I predict the behavior? Now if you are getting continuously this error, given those scenarios, you build a model, you'll say that, hey, next week also I will get this error. Now how do we solve it before this happens? Over a period of time, your error will go.
And also if you're a cloud service provider,
yeah,
and you know who are your customers and what is that they're requesting on a periodic basis, daily, weekly, monthly, how are they increasing their provisioning of IaaS, PaaS or SaaS based on their needs, seasonal needs. Somebody increases their network requirements or hardware requirements on December to Christmas. So if you are tracking all of that data in terms of who your customers are, how are they increasing or decreasing their computing requirements?
Correct.
Hardware, software.
Correct, absolutely.
So you can keep track of that.
Yeah.
And then you can predict your requirements for those customers. And
for next 12 months. Yeah, next 12 months, next 6 months. Correct, absolutely, absolutely. So if there is a behavior, yeah, if there is a behavior and it is stored in some form, data available, you can still model it. If you can model it, you can predict. If you can predict, you can take decisions in advance. Yeah.
In a manufacturing unit, you have huge amount of data coming from sensors. So suppose if there is a daily process going on every day, you are producing some product. We have found a pattern. So is it safe to give a prediction to the machines?
Correct. So if there is a pattern, so like what actions you take?
Safe to give a prediction?
Correct, why not?
But this is not 100% accurate all the time.
Yeah.
How do you know that? It's not 100% accurate.
Because there is some error introduced, right? But still it is not actuals, whatever.
Anyways, there will be a blueprint of some data. They have a
Okay.
data story.
Now let's break it to at a granular level. Now what you are trying to achieve, you are trying to generate some classifications or predictions?
Predictions.
Predictions. You want to say that how many units I would need or how many new units I am going to sell. What is that unit?
Predictions or intelligence to machine.
Of course you can. So yeah, why not? Why not? That's what I'm saying. So you test out the algo. Why not? So like think about the activities that you do. Think about the pipeline first. So like if you think about your scenario, okay, I'm getting from different sensors, I'm getting data. Now what I'm supposed to do? I want to analyze, I want to give some insights out of it. What insights I will give? Something I have to provide to someone, right?
But this could be probably based on the domain. If it is a medical domain where it is some predictions even can cause some injuries or harm.
No, you understand first your downstream. What you want to provide to the next person. What activity the other person is supposed to do. It's a business problem. So you have to...
The ideas are turned down because it's not safe.
Sorry?
Most of the predictive ideas are turned down in the manufacturing industries because it's not safe.
Manufacturing industry is not safe? No, I think you have to structure the problem once again. Structure the problem once again. Manufacturing, there are like so many areas where I have seen like, if you think about this BMW manufacturing plant. Earlier, after the painting happens, there is one human being has to inspect the vehicle, whether there is any chip off of the color somewhere. That is considered as a defect. If the color is spills over to the mirror while painting the side mirror, whether there is a chip off on the steering wheel, there is a chip off on the handle. These are common areas where the painting chip off could happen. One human element, he used to travel through the 360-degree view of the car. He has to notice wherever there is manual register, he has to tick where there is a chip off. Now what is happening? There is a sensor. It moves 360 degree. It recognizes where the defect is, sends the signal to the processing. And the data is analyzed through a machine learning algo to give an early signal that there is a chip off here. You go and correct that. So you have to structure the problem in this way. Now, why not safe? I don't understand. I didn't get that part. Why not safe? Because you are not sending your data to someone.
Safety as in giving predictions.
Oh, you are talking about healthcare? Healthcare, it could be like if you are predicting, okay, my BP will go up 100 by 90 next day. That's not a good thing. Fine. But you should not give it to the individual. You should, like, what level you want to keep the information, it's up to the business to manage. If tomorrow I am getting so and so diseases, someone is telling you, I would not definitely like it. That's fine. You don't have to tell the customer. So what level you want to bring the result, or what level you want to hold the result, that you have to decide. That's a business problem. Yeah?
Automation to some, we are in shipping industry. So when a customer want to send anything, like any goods from one country to another country, we automate it like 80-20. So now the customer books, and earlier we used to take 12 to 14 hours for a confirmation that we have space in the container. So now we use machine learning, and now we have got it to less than 2 hours for confirmation. And there also we filtered out like gold customer. For them we are bringing it within half an hour.
Correct.
So it's very fast now.
Yes.
And we are leaving, we are moving those employees to some other field.
Correct.
So it's like optimization.
Yeah. So this is changing like a lot of industries now. Lot of industries it is changing now. One example is like the tea classification. When you pick up the tea leaves, you put it in bags, you send it to the manufacturing plant. Now there is a tea classification. That's how they pay the prices to the people who are bringing the tea trucks loads. Like, so if I take examples of a major like tea producer in the country, they are receiving thousands of trucks a day. Tea leaves in bags, they are receiving thousands of trucks a day. Now someone has to classify, saying that this is high quality, this is medium quality, this is low quality leaves. If low quality leaves means the entire truck will be labeled as low quality. If one leaf the person picks up randomly, large truck, maybe around 500 cartons, he picks up, opens up one, picks up one leaf, and he labels the entire truck as low, medium or high. There is no supervision here. Because he has to complete 1,000 trucks. Next day another 1,000 trucks will come. And there are so many supervisors, manual supervisors. Now think about the loss to the company. Now what is happening? They have a scanner. It's mandatory to pick one leaf from each carton to put it on a belt. There is a running belt. So all the trucks, once they reach, there is an automated system which picks up the cartons, puts it on the belt. There is an automation system which opens up the carton. There is an automation system which picks up one leaf. It picks up on the label. Now each leaf goes in the belt. There is a scanner, takes the peak, sends it to the algo. Now algo classifies which belt is going on, which carton is going on, which truck is going on. It creates a data set in the back end. Truck number, carton number, leaf, then class. There is an initial training set. The experts, they labeled it. Then the machine learns that. Now the algo is giving a classification saying that high, low, medium. At the time of reaching the plant, there is no classification. You will get your report in the evening in an Excel sheet. In a truck itself, you will find 20 high, 20 medium, 80% or 70% low. Now accurate classification. Now they save millions on this. So there are like this examples you don't know, like in many industries, like there's so many manual stuff happening. It's very difficult to identify because either they are not conversant with the latest technologies, what the technology can bring to them, what technology could save for them, they don't have any idea. So always, that's why I'm saying, do a research on a particular domain, find out the problems that they're existing and how they solve it currently. So coming back to his point, like if tomorrow, let's take my company throws out me, then what will I do? Thing is, I can tell that these are the 10 problems, people solve it this way, I can solve it this way. You give me a chance, I'll solve it. So that's the way you have to tell your potential, saying that I can solve a problem. I'm not here to do a Python coding, I'm not here to do a Spark coding, I'm not do something here of statistical modeling. I'll solve your problem. You tell me your problem, I'll structure your problem, convert it to a statistical problem, build a solution, deploy it, and give output to you. This is how you'll save this much money. So be a problem solver. Always think design. What is the input, what is the output, what processing I'm doing. Clear? Yeah.
Like most of the organization, they want all these to be experienced guys. So how we can start as a fresher in this program?
Correct. So experienced, yeah, I understand that that is like difficult to change. Yeah. So that's correct. But thing is, if you can solve it in a unique way, you'll get a chance.
But they will restrict us. Like if we are not experienced, they won't allow us. So it's like.
Yeah. So
how we can show them like we are having.
Fine. No, this is right. This is right. So to handle this kind of problem, suppose identify what type of data it is, which domain it is. Suppose you are working on, let's take healthcare. You tell me your domain. I'll give a relevant example to you.
Yeah, healthcare.
Healthcare only. So if it is a healthcare, is it like predictive health, preventive health, or recommendation? Which kind of healthcare it is? Right? So if it is a preventive health, it requires diagnostic data. So what type of data it is, you get an understanding, maybe in casual discussions or something. No need to ask data to them. You get an understanding what all fields you are getting. Go to open source, Acadgild, UCI machine learning repository, pick up a similar data set. Whatever experiments you want to do, perform it. Then you tell them that you don't have to share data, you don't have to tell me what problem we are trying to solve, but this is what I built. Would you like to deploy this one here? You show your potential here solving the thing and tell them that this may not be exactly the way you will solve there. I could help you in bringing some more intelligence here to solve it. If they want to take it, fine. They don't want to take it, you get the learning at least. That's fine. Yeah?
I have a specific question on statistics.
Yeah.
In fact, I did statistics in my college, so I'm just really looking at the whole thing. Of course, we understand basic stuff, median code, standard deviation, coefficient of variation, and all that. The distribution curves and the various kinds of charts. I want to migrate to R programming, or at least from a user point of view. So how difficult it is to catch up in R, especially things like chi-square and ANOVA, analysis of variance, and those kind of things. If you know the concept of statistics well, so how difficult it is to port to R programming?
1 week. 1 week enough.
Especially the chi-square variance.
It's very simple. 1 line of code. In R it is 1 line. You just have to say ANOVA, this is my Y.
You need to know the parameters and
Fine. This is my X, this is my data. That's it.
so
1 line.
Fundamental statistics have to do.
Yeah. This is 1 line.
Another thing, in clustering example, suppose I have unsupervised data. So I did some clustering, algo I mentioned, and I clustered to 3 different clusters, segmented to 3 different clusters. So how I will tag different cluster? It's good, bad, or something.
Yeah, so you don't have to tag it. You create group 1, group 2, group 3, group 20. Show it to the user. Ask them, okay, the user said that, okay, 1 and 2 both are similar for me. I want to see both up together equally. You group them together. 3 and 4, I like them. I want them to be together. Group them together. That's the profiling exercise. Post clustering, the profiling exercise has to be done in coordination with the client. Always ask the client, this is what the algo finds 10 groups. Now you tell us how many groups you want to see. The client will tell, okay, you combine 137 as 1. Do that. That's how the business comes into play. Okay, so these are some data points for reference. Okay. Yeah.
And data science and blockchains work together.
Blockchain is another technology.
No, but is there any use cases wherein I can use, say, let's say, predictive fraud detection or whatever, like real-time fraud detection? Can we do that?
Blockchain, I will say that it is it's a new domain which is not tested yet. So to get industry adoption, it has to be tested. So will take some time. Right now, it's difficult to comment upon blockchain. Because many industries, they are testing it now. They haven't seen the real results. So they are just going through the stage of evaluating the technology.
No, but even Narendra Modi, like a couple of days back, he had tweeted about this blockchain thing. So still there, Arun Jaitley says no, they're not even accepting it as cryptocurrency. He's saying crypto asset, but still Narendra Modi is clearly convinced of the capabilities of blockchain, right?
I would not comment upon that because to me blockchain is still it's not evaluated yet. I haven't seen any real use cases where blockchain has solved something major. Absolutely not.
Just using the blockchain, it's 2 different streams. Cryptocurrency is using the blockchain technology. And there are so many other industries are also using the blockchain.
See, like when data science term came, like people think like, okay, data science can solve everything. No, absolutely no. Similarly, machine learning can solve everything. No. Now people thinking like blockchain and AI can solve everything. No, absolutely no. AI can't solve anything until and unless you train them. So human element would be there. You can't take away human element from this blockchain, AI, ML, etc. You have to structure the problem. You have to tell the machine what to do. So similarly, blockchain, like if you're thinking, okay, it's a very foolproof technique, it can solve many things. Absolutely no. Absolutely no. Why? Because how do you frame the problem to a blockchain problem? That is a major task.
Yeah, as I understand. It is only an online nature. For example, if I communicate with you, you are transferring something, some goods, and I am giving money. So later on, both of us cannot reverse back. You cannot say, I will not sell it, I will not sell it, I will not pay it. So everything is tracked through nodes and networks. At every node network, the data is passed through packets.
It's a network. It's basically a network.
And it knows the time, next time, everything is there.
Yeah.
So basically, it's information storage at different points in time.
Correct.
And as far as application of where is concerned, yes. See, wherever information is there, data is there, if you can use that information and predict new things, you can use analytics.
So it's like a one-to-one messaging system. So you are sending something, you need a confirmation. Once you get the confirmation, you are assured that okay, things reached in proper place.
Even within that framework, if you want to capture information, analyze the information, and predict the information, you can use it.
Correct. But blockchain is, again, we have to see where it is going. Banking, well, people say that okay, you can use in banking, it could save millions, security system can be changed, this, that, but I haven't seen a single bank adopting now.
Because there is it eliminates the middleman, simple as that. So they don't want to go out of business.
No, there is no middleman here.
No, but banks are themselves a middleman, right? So if I can send like a crore rupee to you in your Bitcoin wallet, so I don't have to rely on the bank. So that's what I'm.
No.
So why would a bank embrace?
Crypto is a mutual understanding only. It's just a bubble. So like for example, if I am saying that okay, tomorrow my share will be, let's take 200 rupees. Now 5 people get attracted and they pour in money here. Now my 200 becomes virtually 300. Now another 5 people, they pour again money here. Now this becomes 400. This keeps growing. The moment 3 people out of those 5 people feel that it may go down, they withdraw money or they will just stop pouring money, and this will go down.
That's called market forces, right? So that's
no. So this is not again market forces here. There is no as such, there is no market. So this is like completely, it's a sentiment. It's completely sentiment driven. And this is going through now. You must have seen last 1 month how much fluctuation it is having.
No, but this is the first time that bitcoins and all the cryptocurrencies have come to a stable state, if you look at it.
How do you define the stable state?
It's new for people. If you're just noticing bitcoins for a new first time,
correct,
you might see that it has come down from 20 to 10 or whatever it is. But
correct.
This is the first time it has stabilized actually.
Correct.
After like many years.
Fine. So now what if, so this is started by some mining company in Russia. He built the initial trust. Now what if he takes all the 200 millions and he doesn't pay it back? What will you do? It's just mutual faith and trust that's going on.
I'm not just talking about bitcoins, there are 1,000 other cryptocurrencies.
Correct. But
scams, like most
yeah, so it's like a Ponzi scheme.
And if you look from a country point of view, they're not worried because the country has GDP and GNP and a lot of things defined as per economics. The economic of a country will go for a toss if all of this is used suddenly.
No, but economics is by itself a fake concept if you look at it.
It's a mutual understanding. Suppose I have taken money from my friend, whether by hand or through crypto, that is fine. I have taken money and I know this person, I have to pay it back. If I don't pay it back, then?
That's a different, it's like I take money.
This is exactly the same thing. Correct. So this is exactly the same thing here. This is exactly the same thing because tomorrow if like 5 companies, they launch their cryptocurrency, they'll take it back. They'll not, give it back to you. Then what will you do?
That's fine. That's why governments are skeptical and they're saying we have to bring in regulations for all of that.
Correct. Yeah.
My question was actually like, can we use data science in the blockchain scene? Like, predictive fraud detection and stuff like that. Is it possible?
Yeah.
See, to me, if you ask me, if there is a process, it must be generating some data. If there is data, there is some behavior. If there is some behavior, you can still model it. But you have to define what is the task in crypto or blockchain, or what is the task you want to perform.
And who is going to benefit out of that intelligence?
Yeah.
That is important.
What intelligence you want to bring here? Like, are you trying to predict whether the person received my money or not? How do you identify a fraud? Are you defining that somebody is, like this happened with one of my colleague. So he is making investment in this crypto and all. So he put in like 10,000. The bank is saying I have given a confirmation. It is received by them. When they're talking to the company, is saying that I have not received. Now, how do you solve this legal dispute? The government has taken over, saying that no, I'm not responsible for any kind of legal dispute. Now, who will be resolving this issue? You are saying and your bank is saying I have sent money. The company is saying I have not received money. Who is the authority to resolve this issue? You can't take it to the court. Court says that the government doesn't recognize this, scrap it. I am not responsible for this. Now you are losing money. Your money is now gone. Who will solve it? Currently, if you have a transaction successful or failure, still bank is responsible for that. Bank is talking to the merchant. If it is a successful transaction, process it. If it is not, reverse the money back. Bank on behalf, he is responsible for this. Now in this, is there any international court of law where you can take this transaction to? No. Court doesn't recognize this. Court says that it is mutual understanding, you guys handle. It could be, the company could be genuine, you are also genuine. But there is some technological gap, because of that the transaction failed. You are trying to do transaction, your power goes off, the internet shuts down. Some miscommunication happens, transaction is not successful. Then the dispute will be there. For this guy, we are struggling last like 25 days, then after that the company recognizes, oh, we have received this. But the struggle of this 25 days, who will pay the interest on that amount? Right? So the issues will be there. Now how do we resolve those issues? There has to be some mechanism. Right? So that's why before adopting a technology, it is important to understand its nuances. So these are like few terminologies that I have already explained in detail. Okay, so that's all. If you have any questions, you can ask me.
Skills needed for data science.
Sorry?
The skills which are needed for data science.
Correct. So that I think we have discussed in the first slide itself. So if you go back, so there are 4 types of skill sets: programming skill sets, statistical and mathematical skill sets, data visualization skill set, and big data skill set.
Should we know all the programming languages?
I think that's what I told. Like, you start the journey from your domain that you are comfortable.
Only Python and R?
Yeah, of course. You can stick to only one tool, not necessary to start both tools.
So is there any difference between data mining and data science?
Ideal, there is no difference. No difference. Data science is a domain. Data mining, you are particularly looking at a spreadsheet to identify the patterns, to identify relations, to identify behaviors in the data itself. So data mining is within data science itself. If you have a digital face, you will get responses in the form of likes, comments, shares, and feedback. So who will analyze that feedback? Suppose let's take Axis Bank or PNB Bank, let's take. I'm getting so many comments in my Facebook now because of some event or something. Now, can I be just ignoring those things, or should I take any actions on that? I mean, I should be able to understand what those comments are. Like every day 2000 comments are there in the Facebook page. Someone has to analyze it. So what skill sets required for this? Are you going to hire 5 people? You copy this user's ID, copy this content and put it in Excel sheet manually? No. You will need some APIs. You need to know Python. You need to log in yourself as a Facebook developer, open the API, create a login ID, password, access key, access tokens, go to this URL, fetch the comments for this particular post, write one cron there, every day whatever comments come in, directly push it to the database, store it as a CSV. Now that's capturing this, that's one. What if you have already stored? How do you analyze it? You want to do some kind of text mining. You need NLP, natural language processing. You need to understand what text it is, what semantics, is it positive, is it negative? If it is positive, what is positive in it? If it is negative, what is negative in it? Right? So to do this kind of stuff, there are 2 ways. Either you go through manually, 1000 comments a day, you have to read through it and you have to label it as positive, read through it negative, or you want the algo to do this. If you want the algo to do this, you need Python, you need to know analytical library, you need to know natural language processing steps to analyze this. This opens up like huge opportunities. Almost all the large companies, they have a social media team. They have a social media team, right? That's one. Next, video analysis. You have, let's take this new advertisement coming up. Any advertisement you pick up. It's just like 20 seconds video. Who listens to that and who skips? If you want to analyze from YouTube, how do you analyze this? You need someone to analyze this, right? You create API, log in yourself as a YouTube developer, create API access token, get all those videos where your advertisement is displayed, because that you know. You know which videos contain your advertisement. You have, each video will have a unique ID in YouTube. Store these IDs in one CSV, write a cron, take one ID, concatenate with youtube.com, paste it in the URL, go to that video, extract the likes, comments, etc. and find the comments if there is a mention of my advertisement there, and store the activity whether this is skipped or not. Then this is the data capture process only. Post that, if you have like 2,000, 3,000 records, how do you build algo on that? How do you predict? Is there any particular behavior why people skip it? Is there any particular behavior why people listen it? What they like, what they don't like? Should I change my messaging system in my next advertisement video? What needs to be done? Today I have, let's take Ranveer Singh as my brand ambassador, versus tomorrow I'm changing to Virat Kohli. So what is the response? Is there any difference? Right? So this kind of analysis you can perform if you capture the data in a right way, if you capture the analysis in a right way, if you predict or generate classifications in a right way. So opportunities are plenty.
What are the patents you have?
Sorry?
Just to know what are the patents you have?
Yeah, so I have 2 patents still under process. The first patent was like on finding algorithmic way of replacing a product if it goes out of sale. So you have shelf spaces in retail stores. So if a space is empty, then what is the product will replace it there? How do you decide that? Current practice, whatever comes to your mind, you pick up and put it. Algorithmic way, you have to identify the best substitute product.
Merchandising, visual merchandising strategies.
Yeah. Correct. So that I did in 2011. So and it's a like non-linear principal component analysis to identify the best product that need to be substituted. So I applied neural network technique to identify this. So that was in 2011. Yeah.
So for this jobs thing you said, right? So 10 years back, if you look at the industry, like IT industry per se, had a requirement of like 4 to 5 lakh job requirements. The number of people passing out was the same numbers. So today, if you look at the numbers have actually gone up. The number of engineering students coming out from colleges is like more than 10 lakhs today. So but if you look at the industry requirement is less than 2 lakhs. So there's a huge gap. I'm sure like you're having, it's going to open up, that is all fine. So, but is there any evidence that we can, because if at all I'm going to get employed, again I'll have to go to the IT, NASCOM, whatever NASCOM says, I'll have to trust what they say, right? So NASCOM says, okay, there's going to be a very minimal growth because of the Trump issue or H1B processing or whatever it is. So we don't have the kind of growth we saw, definitely going to see in the future. And for data science, because not many companies have the capacity to invest so much money, because you said it's already expensive, there's going to be a limited number of companies who has the kind of money to spend actually. So then the number of people who will be getting into data science, you'll have to be exceptionally good at what you're doing. So it's like 1% of, it's like a creamy layer, you'll have to be there to be getting into this. So that's what I understand.
No. So there are different layers of job here. So like you'll find people who are static, you'll find people at a creamy layer also. Now the problem definition has changed now. Like the integration, digitalization and the communication, it increased 100-fold than last 5 years. So why? Because if you just scroll down the wall of a Facebook, you see the difference in time interval of the posts that is currently and what it was 5 years back. So the communication channel has increased. Digital presence also increased. So if Airtel has like 5 different places, Facebook they have a face, YouTube they have a face, Twitter they have a face. If they have 5 different faces, who is saying what, they have to listen it. Now internally they have to build Facebook team, YouTube team, separate teams for each source, because the volume is increasing. 20,000 comments they are getting in a month.
No, but I get that, but what happens usually is they have a presence for namesake, but ideally they concentrate more on spending money. They want to just advertise and then they try to track that. That's about it. What happens is people, like real people, they go and consume from small time YouTubers or people who have recently become very popular. And then that's what is actually happening. So these companies, they don't build huge teams for different channels, as per my understanding.
No, so they want to analyze. They want to analyze. For example, you just raise this MNP, mobile number portability. They'll go through your history completely, database. Why this customer wants to migrate to another provider? They want to analyze it.
At the end of the day, it's money for companies. In our case, shipping, right? So we used to take 14 hours for one confirmation. The customer is not satisfied. So if we're giving it half an hour information, customer will come back to us.
Correct.
It's end of money.
Yeah.
So my company will invest millions of dollars in this technology.
Yes.
If they don't incorporate, they're going to lose to competition.
Correct. Absolutely.
It's the end of the day.
Yeah.
So actually, if you see, the pressure should be more optimistic.
Exactly.
These kind of technology.
Yes.
Because they don't have much at stake. I mean, initially there won't be much responsibility. Time is there. But now we are into 15 years of industry. We are more optimistic for these kind of technology.
I'll tell you one example, in fact. So this guy is a 19-year-old guy from IIT Madras. Very young guy. So, when he was in college, so he designed a chip which will tell you the disaggregation of electricity. Which device is using how much electricity per second? That device will tell you. So he got a sensor. So he has like 2 patents now on his name. He's only 19-year-old. And he got a funding from Google India head, Rajan Anandan. He has got funding from Google. And he has received awards from Startup India. From Mr. Narendra Modi also he got award. And he has also been crowned as top 20 investors under 20 by Saudi Prince. And he's just 19-year-old. He started this when he was 17. He thought of like, how can I have a mobile app which will tell me that which device is using how much electricity at my home? How do I reduce it? And that translated to a state level problem, where the government can have the similar platform to tell that how much electricity I would need today, tomorrow, day after, to manage the power. Now this guy is doing a prototype in government of Karnataka.
See, I've got a few takes on your question.
Yeah.
See, it also depends on the economic cycle. Say, I don't know the background, but you know that various economic cycles, up and downs, and the slowdowns and the hikes and all that. And also, it also depends on the investment that companies are making. For example, if I'm running a tire company, tire manufacturing company, IT is not my breadwinner. I make my money on selling tires. So, but I need to use IT very judiciously to ensure that my sales are optimal, my supply chains are working properly, my customers are satisfied, I meet all my compliance requirements and all of that. I need IT. IT is my support stuff. But still I sell tires to make my business. Hollywood makes movies and they sell that. That's their main business. But still they use IT. So it all depends on how much extent they keep using IT, and how much they keep using these new technologies, how much they are ready to invest. It all depends on that. So obviously there will be jobs, And another thing is
There will be better jobs. I will say better jobs.
better job. If you look at India itself, we are not using IT to a large extent. So today there is a need within India itself, right from government to railways to defense, to everybody to use more of IT. And those users, defense users, airways, railways, more they start investing and obviously there is more jobs. It goes like that.
Like the cars that are coming now, so it will tell you what is the lifetime of a tire.
It gives you car, what is that?
Predictive maintenance. So when should you change the engine oil? When should the tires need to be changed? Yeah, yeah. Exactly. So it will give you a dashboard report, send it to your mobile phone.
See, what has happened is the technology landscape that you were in 20 years back, that is not holding so good because of the changing dynamics. Because everybody has an ERP system.
Yeah.
Every big company has a transactional system. Everybody does stuff. I mean regular stuff. So Walmart has the supply chain application, they have the CRM applications, they have the ERPs, everything is there. So they are doing delta increment. So they need to look at what else we can do. So what else we can do, they need to bring investment. And jobs we go into those.
Now even in ERP systems also, so
ERP analytics.
that's storing the data.
Yeah. It's a transactional systems, yeah.
Correct. Now, I mean, what is there that will give me an extra mileage?
It's already there. So
What is the insight? What is the insight I'll get from that?
No, what I'm saying is, Walmart as a company already has the systems in place.
Correct.
So if I have to put my systems in place, why should I put that extra $1 on my IT as an entrepreneur? I'm the chief of Walmart. Why should I put $1 more? Because I should get a business benefit. So I'll think of spending $1 more where I get maximum mileage. It's called marginal utility, right?
Now, the car example, once you this predictive maintenance. For the user, it is just a satisfaction saying that, okay, I know when to change the tires, I know when to change the engine oil, etc. Now think of the tire manufacturer. They will get an aggregate saying that, okay, 20,000 tires I will need this month. So I can do a demand planning better. Now engine oil company, if he says, okay, 1 million units of engine oil I would need this month, that's a big business for them and they have to plan it accordingly. So there is upstream, downstream both. So for the user, consumer, it's just the information, jazzy information you are getting on mobile app. Hey, you need to change your tire, you need to change your fuel, etc., engine oil, etc. But for the company, the same data they are also sharing. Right?
Because the reason why I told you this was because if you look at, I'm talking about data. So Obama, when he stepped out, so he was talking about the jobs data, right? So you're saying 98% of the jobs are being created compared to the previous whatever years it was. But what happened was, what he suppressed was like more than 95% of the jobs that was created was based on gig-based economy. Like it's like a one-time job that was created actually. So if you look at India again, so highest unemployment rate is already there compared to any other country, like 4 to 5% unemployment rate. So if I have, we cannot solve problems right now here. So how do you expect? Okay, the situation is going to be
only ways.
What's going to happen? So I'm talking reality. I'm talking ground reality.
Correct.
What's already happened.
Correct. So the ground reality will only improve when you upskill yourself. That is the only answer. That is the only answer. See, problems are now, thousands of problems are still there. But it's being a typical Indian mindset, everybody is doing a jugaad.
So I will apply a classification solution to that. See, as India, we need to look at, this is what Prime Minister and the team has to look at. They need to look at what is the population of youth in India as of today, and what category they fit into. Are they engineers, are they doctors, are they low-level workers, are they unqualified workers? That classification has to be there. Because nowadays with other and other things, you can get persons, demographics. And they also have to see which industries India has to participate more. For example, India has to be primarily agriculture country. India is not an IT country by birth. We got so many villages. You go to Dubai or UAE, there are no villages. There are only cities, that's all. Australia, only cities. India has 50,000 villages. So we are primarily an agrarian country. And to be an agrarian country, we need to increase agriculture penetration and we are exporting agriculture economy just like China is. And for that to happen, agriculture and IT has to get married. A poor farmer like me working in a rural village, in which state you come from? Tamil Nadu. Working in Salem, smallest village. I should have a lot of information on my fingertips. Right? What kind of crops to seed? What kind of pesticides?
What kind of diseases I need to address?
So I should have all information. Through information, I need to manage my fields, unlike a villager earlier days. So a person like me who can be an IT professional, but I also manage my forms. So I don't suffer from an unemployed problem. So it is time for Indian youth to reconsider the employment opportunities. Because
see another example.
Can I be a part of movie making industry? Can I be part of?
See another example. So there was a recent opening in railway clerical jobs. 800 PhDs applied for railway clerical job. Why?
It's a secure employment. Railways are biggest requires.
Because PhDs are not meant for railway clerical jobs. Because they can't do the PhD job.
Yeah, they just.
Right? They can't do the PhD job, that's why they are applying there. Right? So there is a requirement, there is a skill gap. On paper they have skill sets, but they can't do the real work. But PhDs, like there are 20,000 PhDs required in all the universities now. Why can't they teach as a PhD or professor? There are so many assistant professor positions open across government universities, and why can't they compete there? Why can't they fight there? Okay, I can teach better. Why they are applying for a railway clerical job? Right?
There is absolute shortage of doctors in India.
Yeah.
Look at any advertisement, government doctors required, veterinarians required. Salary is good enough, better than IT service. People are not going there because people want to be, working in a big city, comfortable, luxury, IT and all that. No, that will change. It has to change.
Anyway, you have IBM Watson coming, so.
See, Watson coming, so everybody is knowing since last 10 years. Anyone seen our Watson?
Seen, but heard about
So Bluemix knows not Watson. Bluemix and this Watson Analytics, it's not Watson. Watson Analytics, you upload a CSV file, it will frame a hypothesis saying that whether you are looking at correlation between so and so, you click on that, it will show a graph. That's Watson Analytics. Bluemix, you have a database, you connect it to that, you perform some activities, then you define what you want to do, run it, it will show you prediction or classifications. It's again just like another like NIME or Weka. So these are like UI based tool that gives a front end to the user who cannot program. You just drag and drop, select, connect the nodes, you run the model. Like SAS E-miner.
Acadgild. Average is dead.